Industrial Control Photosensors Explained Beginner's Guide to Photoelectric Sensors in Automation. Have you ever wondered how factories can automatically detect when a product is in the right position without anyone touching it? Or how a conveyor belt can count hundreds of items per minute with perfect accuracy? The secret is a small but powerful device called a photoelectric sensor, or as we call them in the automation world, photosensors. In this video, we are going to break down exactly how they work, the different types you'll encounter in industry, and how to choose the right one for your automation project. So, whether you're an engineering student, a technician, or just curious about how smart machines detect objects, stick around, because by the end of this video, you'll understand industrial photosensors inside out. What is a photosensor? A photosensor is an electronic device that uses light to detect the presence, absence, or position of an object without physically touching it. In industrial control systems, these sensors act like the eyes of a machine. They send out a beam of light, usually infrared, visible red, or even a laser, and then watch for changes in that beam. If an object blocks it, reflects it, or changes it in some way, the sensor reacts and sends an electrical signal to the control system, like a PLC. Think of it like a garage door safety sensor. When something blocks the beam, the door stops. Now imagine that same principle, but scaled up and adapted for high-speed production lines, robotic arms, and automated warehouses. Why use photosensors? So, why are photosensors such a big deal in industrial automation? Well, here are the top reasons. Non-contact detection. They can sense objects without physical contact, which means less wear and tear and no contamination risk. High speed. They can detect objects moving hundreds of times per second. Versatility. They work with metals, plastics, glass, paper, liquids, and even transparent materials with special models. Long range. Some types can detect objects several meters away. Precision. Perfect for positioning systems and counting applications. If limit switches are like the fingertips of a machine, then photosensors are like the machine's eyes, fast, accurate, and able to see from a distance. Main types of photosensors. 1. Through-beam sensors. Through-beam sensors are considered the most reliable type of photoelectric sensors. Here's how they work. You have two separate units. One is the emitter, and the other is the receiver. The emitter sends out a continuous beam of light directly across to the receiver, almost like an invisible laser bridge. Now, imagine what happens when an object moves between them. The beam of light is interrupted or blocked. The receiver instantly detects this break in the signal, and that's what causes the sensor to trigger an output. Because the light travels in a straight line from emitter to receiver, through-beam sensors can cover longer distances compared to other types of photoelectric sensors. In fact, some industrial models can detect objects several meters away with very high accuracy. This design also makes them very reliable, because the beam is strong and easy for the receiver to detect. Even in environments with dust, smoke, or other background light, through-beam sensors still perform better than other sensor types. However, there's one drawback. You always need two devices installed opposite each other, the emitter on one side and the receiver on the other. This means more wiring and more installation effort compared to single-unit sensors like reflective or diffuse types. Despite that, they are widely used in industrial automation. For example, detecting items moving on a conveyor belt, counting bottles in a filling line, monitoring if an object passes through a safety gate. So in short, through-beam sensors are the go-to choice when reliability and long detection ranges are most important. Advantages. Longer sensing range, often 10 meters or more. Very reliable, even in dusty or dirty environments. Drawback. Requires two mounting points and careful alignment. Example. Imagine a bottle filling line. A through-beam sensor can detect if a bottle is missing from the conveyor, stopping the filler before it spills. 2. Retroreflective sensors. Retroreflective sensors take a slightly different approach compared to through-beam sensors. In this design, both the emitter and the receiver are housed together in one single unit. Instead of needing two separate devices, you place a reflector directly opposite the sensor. Here's how it works. The emitter sends out a beam of light toward the reflector. The reflector then bounces the light back into the receiver. As long as the beam returns uninterrupted, the sensor knows the path is clear. But when an object passes between the sensor and the reflector, it blocks or interrupts the light. The receiver no longer sees the reflected signal, and this triggers the sensor's output. One big advantage of retroreflective sensors is ease of installation. Unlike through-beam sensors that require wiring on both sides, here you only need to mount the sensor on one side, while the reflector, which doesn't need power, goes on the opposite side. This makes it more cost-effective and simpler to set up. Retroreflective sensors can also cover medium to long distances, though not quite as far as true through-beam sensors. They're very popular in automation because of their balance between reliability and convenience. However, there are some limitations. If you're trying to detect shiny or reflective objects, like glass bottles or polished metal, the sensor might get confused, because the object itself could reflect the light back to the receiver, tricking the system into thinking nothing is there. To solve this, special polarized retroreflective sensors are often used, which filter out unwanted reflections. You'll often find retroreflective sensors in applications such as detecting packages on conveyors, sensing vehicles at entry barriers, monitoring objects in automated storage and retrieval systems. In summary, retroreflective sensors are a smart middle ground. They're easier to install than through-beam sensors, offer reliable detection over longer distances than diffuse sensors, and are widely used in industrial environments. Advantages: only one wiring point, the sensor. Good sensing distance, usually up to 5 to 10 meters. Drawback: shiny objects can cause false triggers unless you use polarized filters. Example: think of an automated car wash detecting the presence of a vehicle between wash stages. 3. Diffuse reflective sensors. Diffuse reflective sensors take simplicity to the next level. Just like retroreflective sensors, the emitter and receiver are housed together in a single unit. But here's the difference. There's no reflector placed opposite the sensor. Instead, the object itself becomes the reflector. Here's how it works. The emitter sends out a beam of light into the open space. When an object enters that space, the light hits the object's surface and is scattered or reflected back toward the receiver. If enough light bounces back, the sensor recognizes the presence of the object and triggers an output. This design makes diffuse sensors very easy to install, because you only need one device and no extra reflector. You just mount the sensor, aim it at the target area, and it's ready to go. However, this convenience comes with some trade-offs. Since the sensor depends on how well the object's surface reflects light, detection can vary. Shiny, dark, or transparent objects may reflect light poorly or inconsistently, which can lead to unreliable detection. For example, a shiny plastic object might reflect light away instead of back to the receiver, while a dark object might absorb most of the light. Because of this, diffuse reflective sensors typically have a shorter detection range compared to through-beam or retroreflective sensors. They're best suited for close-range applications where the target object has a reasonably good reflective surface. You'll often find them used in detecting products on assembly lines, counting items as they pass by, presence detection in packaging or labeling machines. To improve performance, some diffuse sensors use background suppression technology, which allows them to better distinguish between the target object and surrounding surfaces, making them much more reliable in tricky environments. In short, diffuse reflective sensors are the simplest and most compact option. They're cost-effective, easy to install, and work well for many everyday automation tasks, but they are best for shorter distances and consistent object surfaces. Advantages: very easy to install, just point at the object's path. Drawbacks: shorter range, a few centimeters to 1 to 2 meters. Performance depends on the color and surface finish of the object. Example: used for detecting passing packages in a sorting line. 4. Laser photoelectric sensors. These use a focused laser beam instead of LED light. They're perfect for small object detection, long range, or precise positioning. Example: positioning car bodies in a welding robot cell. Choosing the right photosensor. When selecting a photosensor, consider range. How far is the object from the sensor? Object properties. Is it shiny, transparent, small, or dark? Environment. Will there be dust, moisture, vibration, or temperature extremes? Speed. How fast are the objects moving? Mounting space. Can you fit 2 units, or just 1? Choosing the right type ensures reliable detection and avoids costly downtime. Real-world applications. Photosensors are everywhere in industry. Counting products on a packaging line. Positioning materials for robotic welding. Detecting jammed items in sorting systems. Safety light curtains for machine guarding. Detecting transparent bottles in beverage lines. On-SC maintenance and troubleshooting. Like any sensor, photosensors need regular cleaning, especially in dusty or oily environments. Check for misalignment, loose wiring, and dirty lenses. A quick wipe and realignment can often fix detection issues. Conclusion. So that's the world of industrial photosensors, the eyes of modern automation. From detecting tiny screws to positioning entire vehicles, they're essential for reliable, high-speed production. If you found this guide useful, don't forget to like, subscribe, and hit the bell so you never miss our future automation deep dives. This is the Control Brainiac, where industrial control systems come to life.